Imagine this. You're standing on Earth, but it's not the Earth you know. The sky above is darker, the constellations unrecognizable, and a deep, eerie silence hangs in the air. The familiar moon, the celestial companion that has guided our tides for billions of years, is missing. The world around you feels alien, and for good reason. This is Earth, but 1 billion years in the future. The universe itself has transformed in ways we can barely comprehend. The stars that once lit up the night sky are gone, replaced by new cosmic giants, some burning with a ferocity never before seen. Black holes, once rare and distant, have grown more powerful, lurking in the fabric of space like silent predators. Even our own galaxy, the Milky Way, is no longer as we remember it. But how did we get here? What has changed? And what does this distant, unimaginable future truly look like? Before we unravel these cosmic mysteries, let's take a small step together. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps. Let's grow this community together. All right, let's begin our journey 1 billion years into the future. The first thing we need to understand is how time affects everything in the universe, starting with our very own solar system. The fate of Earth and the Sun. Let's begin with the Sun, the very heart of our existence. Right now, it's a relatively stable main-sequence star, steadily converting hydrogen into helium in a process that has powered life on Earth for over 4.5 billion years. But this process isn't infinite. Over time, as the Sun burns through its hydrogen fuel, it becomes hotter and more luminous. Fast forward 1 billion years, and the Sun's brightness will have increased by nearly 10%. At first glance, that might not seem like a lot, but in terms of planetary survival, it's catastrophic. The increased energy from the Sun will trigger a runaway greenhouse effect on Earth. The same process that made Venus the scorching, inhospitable hellscape it is today will now take hold of our home planet. The oceans, once vast and teeming with life, will begin to evaporate at an accelerated rate. Water vapor, a powerful greenhouse gas, will trap even more heat, pushing temperatures to extremes never before seen. Within just a few million years of this process beginning, Earth's surface will become utterly uninhabitable. Imagine standing where an ocean once was, perhaps the Pacific or the Atlantic. Instead of deep blue waters stretching to the horizon, all that remains is a vast desert of cracked, scorched earth. The seafloors, now exposed, rise like jagged mountains, shaped by the ancient movements of tectonic plates. The air is thick with carbon dioxide, and the temperature on the surface is well over 300 degrees Fahrenheit. Not even the hardiest extremophiles, microorganisms that today survive in deep-sea vents and radioactive environments, will be able to withstand these conditions. Earth, once a paradise, will be nothing more than a lifeless rock, slowly roasting under an unforgiving sun. And what about the Moon? Will it still be orbiting Earth as it does today? Surprisingly, no. Due to tidal interactions with our planet, the Moon has been gradually moving away from Earth by about 1.5 inches per year. Over 1 billion years, this subtle shift adds up. While the Moon won't have completely drifted away, its distance will be significantly greater. The night sky, once graced by its familiar glow, will feel emptier. And without the Moon's stabilizing gravitational pull, Earth's axial tilt could fluctuate more dramatically, leading to unpredictable climate shifts in its final years. What about Mars? A second chance for life. But while Earth is turning into a cosmic wasteland, what about Mars? Today, the red planet is a frozen desert with an atmosphere too thin to support liquid water on its surface. However, as the Sun grows hotter, Mars will receive more warmth. This could trigger temporary climate shifts, allowing for brief periods of liquid water to form. Rivers could carve new paths into the Martian soil, and ancient ice caps might melt, at least partially. Could this mean a second chance for life? Could organisms hidden beneath the Martian surface find a way to emerge and thrive? Or will Mars, like Earth, eventually succumb to the Sun's growing intensity, its thin atmosphere stripped away by relentless solar winds? The answer is uncertain. But if humanity has found a way to colonize the red planet by this time, Our distant descendants may be among the last to witness the final days of a once blue Earth. The collision of galaxies, the birth of Milkomeda. As Earth and Mars struggle under the weight of time, the universe continues its own cosmic evolution. One of the most dramatic transformations underway is the impending collision between the Milky Way and its neighboring galaxy, Andromeda. This is no mere hypothesis. This event is inevitable, dictated by the unstoppable laws of gravity. Right now, Andromeda is racing toward us at nearly 70 miles per second. It still appears as a distant, hazy smudge in the night sky, but in 1 billion years, that will no longer be the case. By then, Andromeda and the Milky Way will be deep into their collision, their structures warping and twisting as they merge into one massive galaxy, what astronomers call Milkomeda. Imagine looking up at the night sky and seeing not just a band of stars like we do today, but a chaotic swirl of entire galactic arms crashing into each other. Countless stars will be thrown into deep space, flung away by gravitational forces beyond comprehension. Some solar systems will be torn apart, their planets ejected into the void between galaxies. Others will find themselves drifting into entirely new cosmic neighborhoods. But what about our Sun? Will it survive this cosmic reshuffling? Surprisingly, the answer is yes. Despite the dramatic visuals of a galactic collision, the vast distances between individual stars mean that direct collisions between them are incredibly rare. Our Sun will likely settle into a new orbit within the newly formed Milkomeda galaxy. However, the night sky will never be the same again. Instead of a familiar, calm Milky Way, our descendants, if any still exist, will witness a night filled with whirling galaxies, colossal dust clouds, and the glow of newborn stars forged in the chaos. The expanding void, a darker future. But even as new stars are born in this collision, the larger fate of the universe is one of growing emptiness. Dark energy, the mysterious force driving the accelerated expansion of the cosmos, will continue to push galaxies farther and farther apart. The distant galaxies we see today, those lying billions of light-years away, will become unreachable, their light red-shifted beyond visibility. Eventually, only a handful of galaxies will remain within our observable horizon, as everything else drifts into an unreachable abyss. 1 billion years from now, the universe will already be on its way to a much darker future, one where isolation, entropy, and decay will become the defining forces of existence. But what comes next? Will new stars continue to form, or are we nearing the twilight of cosmic creation? And what of black holes? Will they continue to grow, devouring what remains of the universe? The answers lie ahead, in the vast and mysterious future of our ever-changing cosmos. The universe never rests. Even as planets burn, galaxies collide, and stars fade away, cosmic forces continue their relentless work, reshaping existence in ways that defy imagination. 1 billion years is an almost incomprehensible stretch of time, yet in the grand scheme of the cosmos, it is but a single breath. What happens next? Will the stars keep shining, or are we moving toward a darker, quieter universe? And what of black holes, the mysterious behemoths lurking in the depths of space? Are they growing, merging, and consuming everything in their path? To answer these questions, we must step beyond our own solar system and dive into the very heart of the universe's transformation. The last generations of stars, one of the most profound changes happening over the next billion years, is the slow but inevitable shift in the universe's stellar population. The stars we see today, brilliant blue giants, steady yellow dwarfs like our Sun, and ancient red dwarfs, are all engaged in a battle against time. But as the eons pass, this cosmic battlefield will start to look very different. The largest and most massive stars, the blue supergiants, are living on borrowed time. These celestial titans burn through their fuel at an astonishing rate, lasting only a few million years before erupting in spectacular supernovae. A billion years from now, the vast majority of these short-lived giants will be gone, leaving behind dense neutron stars and the all-consuming black holes born from their fiery deaths. But what about stars like our Sun? These mid-sized stars enjoy much longer lifespans, typically around 10 billion years. Given that our Sun is about 4.5 billion years old today, by the time we jump forward a billion years, it will be entering the latter stages of its life. The Sun will have become hotter and more unstable, its outer layers swelling as it begins its slow transformation into a red giant. It won't happen overnight. This is a process that takes hundreds of millions of years, but the changes will be unmistakable. Yet for all the chaos and destruction, not all stars are doomed so quickly. The real survivors of the universe are the red dwarfs, small, cool stars that burn their fuel with remarkable efficiency. Some of these stars will last for trillions of years, meaning that even a billion years from now, many of them will still be shining, as steady and quiet as ever. In fact, red dwarfs may become the dominant type of star left in the cosmos, their slow-burning light outlasting almost everything else. But there's another, more unsettling possibility. If new star formation slows down, we could be entering an era where the universe starts running out of fresh young stars. Every star that dies is not being replaced as quickly as before. Is the cosmos already heading toward its inevitable fate, an age where no new stars are born at all? The growing hunger of black holes, as some stars fade, others give birth to something even more mysterious: black holes. These objects, the collapsed remnants of the most massive stars, have an insatiable appetite for matter and energy, and over the course of a billion years, they have only one goal: to grow. But how do black holes grow? They feast. Whenever a star strays too close, its gases are ripped apart, spiraling into a fiery disk before vanishing beyond the event horizon, never to return. And it's not just stars. Entire planets, clouds of gas, even other black holes can be devoured. In the relentless hunger of these cosmic titans, the Milky Way's central black hole, Sagittarius A star, is already 4 million times the mass of our Sun. But in a billion years after the collision with Andromeda, it will have likely merged with Andromeda's supermassive black hole, forming an even larger gravitational monster. The result: a supermassive black hole potentially hundreds of millions of times the Sun's mass, dominating the heart of the newly formed Milky galaxy. And yet, there is something even more mind-boggling to consider. If black holes continue to grow unchecked, could they eventually consume everything? Could they become so powerful that the universe itself is dominated by their gravitational pull? For now, the answer is no. Despite their terrifying nature, black holes don't expand like a cosmic plague. They only consume what drifts too close. But in the far, far future, long after a billion years, they could become some of the last objects left in existence. The cosmic web and the expanding void beyond. In the dance of stars and the hunger of black holes, there is an even grander force shaping the future: dark energy. This invisible force is responsible for the accelerating expansion of the universe. Pulling galaxies apart faster than gravity can hold them together. A billion years from now, this effect will be more pronounced than ever. Today, we still see distant galaxies in the night sky, their light traveling for billions of years to reach us. But as dark energy continues its relentless push, many of these galaxies will have drifted so far away that their light will no longer be able to reach us at all. Imagine standing beneath a night sky 1 billion years from now. Instead of seeing a cosmos filled with billions of galaxies, the view will be far emptier. The Milky Way, Andromeda, and a few neighboring galaxies in our local group will still be visible, but beyond that, nothing. The distant galaxies will have moved beyond the observable horizon, forever lost to us. This means something profound. Future civilizations, if they exist, may never know that the wider universe was once filled with countless galaxies. To them, the cosmos might seem small, quiet, and lonely, with only their own galaxy as a reference. The grand history of cosmic expansion could be lost to time itself. The unfolding mystery of life, with so many stars dying, black holes growing, and galaxies vanishing beyond the cosmic horizon, one might ask. What about life? Could something somewhere have survived? 1 billion years ago, Earth was a very different place. Life had already existed for over 3 billion years, but there were no plants, no animals, and no humans. Instead, Earth was dominated by microscopic life forms, the ancestors of everything that would come later. Life can be incredibly resilient, adapting to extreme environments and surviving conditions that seem impossible. If life could endure for billions of years in the past, could it still exist in the distant future? And if Earth is doomed, could intelligent civilizations elsewhere have found a way to escape the fate of their own planets? Perhaps, among the countless exoplanets scattered across the cosmos, life has found ways to endure, even as the universe grows colder and darker. Perhaps alien civilizations have long since abandoned planetary surfaces, living instead on colossal space stations or in artificial megastructures built to withstand the ravages of time. Or perhaps the last remnants of life are waiting, hidden beneath the ice of distant moons, buried within the clouds of gas giants, or clinging to the last surviving red dwarfs. 1 billion years is long enough for life to evolve in ways we cannot even begin to imagine. So where does the story of the universe go from here? Will the era of life and light continue, or are we moving toward a future where darkness reigns? And if the universe is expanding, will it eventually tear itself apart? Time is the great sculptor of the cosmos, shaping galaxies, stars, and even the very fabric of space itself. As we journey another billion years into the future, we enter an era where the universe is no longer the same familiar place we once knew. The celestial landmarks of our time, the constellations, the planets, even the great spiral arms of our galaxy, have shifted beyond recognition. The Milky Way and Andromeda have long since merged into a single galactic colossus. The Sun, once the life-giver of Earth, has changed forever, and the relentless force of dark energy continues to stretch the universe apart, like an unseen hand pulling reality to its breaking point. But what does this mean for the grand cosmic story? Have the last flames of creation been extinguished, or is there still room for something new? To understand this future, we must dive into the heart of a universe in transition, a universe approaching the dawn of its final age. The fading light, a universe in decline. For billions of years, the universe has been a place of light, fueled by the birth and death of stars. But as time marches on, the balance shifts. By now, the vast majority of large, bright stars have already lived out their short, fiery lifespans. Supernova explosions, once common, are now rare, as fewer massive stars remain to detonate in their brilliant deaths. With each passing eon, fewer stars are born to replace the ones that fade away. The great star-forming nebulae, vast clouds of gas and dust that once glowed with the promise of new suns, have been used up or dispersed. The young hot blue stars that once illuminated galaxies have burned through their fuel and vanished. What remains are the dimmer, longer-lived stars, mostly red dwarfs, still glowing steadily but lacking the intensity of their massive predecessors. If you were to look at the night sky now, it would appear vastly different. The once vibrant clusters of bright stars are gone. Instead, space is filled with an eerie reddish glow from the surviving low-mass stars. The universe has not gone completely dark yet. But it is undeniably quieter. And then there is the fate of our own sun, the death of our star, the white dwarf era. 1 billion years ago, the sun was still a main sequence star, steadily burning hydrogen in its core, but time has changed it. Now it has long since swollen into a red giant, consuming the inner planets in its expanding inferno. Mercury and Venus have been utterly obliterated, and Earth, if it was not already reduced to a scorched wasteland, has been consumed in the fiery embrace of its dying star. But even red giants do not last forever. After shedding its outer layers into space, the sun has left behind a new form, its final stage of existence, a white dwarf. A white dwarf is the remnant core of a once mighty star, a super-dense object no larger than Earth, but containing nearly all of the sun's original mass. In this state, the sun no longer burns with the fire of nuclear fusion. Instead, it glows only from the residual heat left over from its past life. Over time, it will cool, fading ever so slowly into darkness. But even in this diminished state, it may still have company. If any of the outer planets, Jupiter, Saturn, Uranus, or Neptune, survive the chaos of the sun's transformation, they may continue to orbit their dim, dead star like ghosts of a bygone era. Perhaps in some distant future, The frozen moons of these planets could still hold secrets. Ancient oceans trapped beneath layers of ice, remnants of a solar system long past its prime. The reign of black holes, galactic monsters, while the universe's stars are fading. There is one type of object that continues to grow: the black holes. By now, black holes dominate the galactic landscape. The supermassive black hole at the center of Milkomeda, the merged form of the Milky Way and Andromeda, has swollen to an almost unimaginable size, likely surpassing hundreds of millions of times the mass of the Sun. Having devoured countless stars, gas clouds, and perhaps even smaller black holes, this cosmic leviathan now presides over a galaxy that has grown quieter and darker with age. But beyond the supermassive black holes, something even more bizarre is happening. Over time, stellar mass black holes, the remnants of collapsed stars, have begun to merge. When two black holes collide, they create ripples in the very fabric of space-time, gravitational waves that echo across the cosmos. These mergers have been happening for billions of years, and with each collision, the resulting black hole becomes larger and more powerful. Is it possible that one day, black holes will merge into such enormous structures that they become the dominant force in the universe? Could a time come when the cosmos is nothing but a scattered collection of dead stars, fading remnants, and monstrous black holes? For now, the universe still holds onto its last traces of light. But the forces shaping its fate are already at work. The expansion problem, a universe growing. Cold even as black holes grow, dark energy continues its relentless work. The universe is expanding at an ever-accelerating pace, and by now the effects are undeniable. Galaxies that were once within reach have disappeared beyond the cosmic horizon, their light redshifted into oblivion. If there are still intelligent beings somewhere in the universe, they will see a vastly different sky than the one we know today. Instead of a cosmos teeming with billions of galaxies, they will only see their local cluster, a handful of nearby galaxies still held together by gravity, while everything else drifts into unreachable darkness. This means that intergalactic travel, if it was ever possible, is now nearly impossible. The vast distances between galaxies have stretched beyond what even the fastest possible spaceships could ever cross. Civilizations, if they exist, will find themselves in growing isolation, forever cut off from the wider cosmos. And yet, even now, the story of the universe is not quite over. There are still questions left unanswered. If black holes continue to grow, will they one day swallow everything? Will the expansion of the universe rip apart even the fabric of space itself? And what of life? Has it found a way to endure? The next billion years will take us even closer to the twilight of the cosmos. We are now entering the final act of existence, a time when the last embers of creation begin to flicker out. But before the universe fades completely, there may yet be one last mystery to unravel. The universe has always been a stage for the grandest of dramas, a place where stars are born in brilliant explosions of light, where galaxies dance in slow, majestic collisions, and where black holes lurk as silent, insatiable voids. But every story must have an ending. 1 billion years from now, we have seen the slow fading of the cosmos, stars dwindling, galaxies drifting apart, and black holes growing ever more powerful. Yet, the future still holds mysteries untold. Are we heading toward a silent, frozen eternity? Or is there a final act, an unexpected twist waiting beyond the veil of time? The universe may be fading, but it is not yet dead. The last sparks of life. Even in a universe growing colder and darker, life is stubborn. It clings to existence in ways that defy imagination. Over the past billion years, civilizations, if they emerged, have faced unimaginable challenges. Planets became uninhabitable. Stars swelled, burned out, and collapsed. Galaxies moved beyond reach, cutting off entire worlds from each other forever. But life has always been an architect of survival. If intelligent beings endured, they would have adapted. They might have abandoned planets long ago, constructing vast spacefaring habitats, powered by the dying embers of ancient stars. They could have harnessed the energy of black holes, using their immense gravitational forces as power sources in ways we cannot yet comprehend. And then there are the strangest possibilities. Could life have moved beyond biology itself? In a universe that has changed so much, could the last survivors exist as digital consciousness, uploaded into vast artificial networks built to withstand the ravages of time? Could minds, freed from the constraints of flesh, continue to think, to dream, to wonder, even as the stars themselves vanish? Or perhaps in some hidden corner of the cosmos, a tiny, forgotten world still harbors a spark of biological life. Beneath the thick ice of a distant exomoon, near the last embers of a dying red dwarf, microscopic creatures drift in a dark, alien ocean, unaware that they may be among the last living things in existence. The ultimate fate of black holes. Hyun's black holes have been the universe's final rulers, the remnants of long-dead stars, the supermassive behemoths at the hearts of galaxies. These cosmic giants have only grown larger and more powerful. By now, they are among the last major structures still shaping the universe, but even black holes have a weakness. A phenomenon known as Hawking radiation, a process predicted by physicist Stephen Hawking, suggests that black holes are not completely eternal. Over unimaginable stretches of time, they slowly leak energy and shrink, until one day they simply evaporate. The catch. This process takes longer than the current age of the universe by a mind-numbing degree. But as we peer further into the future, into the distant shadows beyond 1 billion years, we reach an era where even the mightiest black holes will begin to fade. One by one, they will evaporate, releasing their last bursts of energy into the cold, empty void. The largest black holes, those with masses billions of times that of the Sun, will be the final ones to disappear, whispering away their existence in ghostly flashes of radiation. When the last black hole vanishes, the universe will be left with nothing. The final curtain, a universe of darkness. At last, we reach the ultimate fate of the cosmos. No stars, no planets, no galaxies, no black holes. The universe, once a place of unimaginable energy and light, is now a cold, dark void. The only thing that remains is a thin mist of elementary particles spread across a cosmos that has stretched beyond comprehension. This is the era known as the heat death of the universe, the moment when all energy is evenly distributed and no more work can be done, no more structures can form, no more movement can occur. Time itself loses meaning. Some theories suggest that this is truly the end, a universe that has entered an eternal sleep, never to awaken. Others propose more exotic possibilities. Could quantum fluctuations, tiny random changes in energy, one day trigger the birth of a new universe? Could the cosmic cycle repeat, with a new Big Bang igniting existence once more? Or is there something even stranger waiting for us at the end of time? The final question: does the universe have a purpose? As we reach the limits of what we can predict, one question lingers. What was it all for? Did the universe arise from nothing only to fade into nothing once more? Or was there meaning in the brief moments when galaxies shone, when planets formed, when life, however briefly, looked up at the sky and wondered? Perhaps this is the ultimate gift of the cosmos, not an answer but a question for whoever is left to ask it, a question for us. If this journey through time has left you with questions, with a sense of awe, or even a spark of existential curiosity, then don't let the conversation end here. Like this video, share it with others who love unraveling the mysteries of existence, and tell us your thoughts in the comments. What do you think the future of the universe holds? Do you believe in an ultimate end? Or could something even more unexpected be waiting?